Our question tonight is, use the following standard enthalpies of combustion of graphite, hydrogen, and enthalpy of formation of propane. We have enthalpy of combustion of graphite, which is just carbon, minus 393 kilojoules per mole. We have the enthalpy of combustion of hydrogen, minus 286 kilojoules per mole. And then we have the enthalpy of formation of propane, which is minus 104 kilojoules per mole. The first question is asking, write the equation for the formation of propane. How do you write the equation? Yes, propane is C3H8, meaning it is formed by 3 carbon atoms, and then it is also formed by 4 moles of hydrogen. Hydrogen is diatomic. You always need to write it this way, and 4 moles of them will form what is called propane. The next question is asking, draw an energy cycle diagram that links the heat of formation of propane with the states of combustion of graphite and hydrogen. This is what it looks like. We have the enthalpy of formation on top there, and then we have the enthalpies of combustion of carbon and hydrogen. This is the enthalpy of combustion of propane. What do you need to be careful about here? Yes, you need to balance the number of carbons and the number of hydrogens. In all the cases, you'll find that they always balance. But what always changes are the number of oxygens. That when you're burning, for example, 3 moles of carbon, how many moles of oxygen will you require? You find you need 3 of them. The same with hydrogen, you need to calculate how many moles are required when you're burning 4 moles of hydrogen. You'll find that you'll need 4 atoms of oxygen are required, so you need 2 moles of oxygen here. Then if you're burning propane itself, you're going to form carbon dioxide and water. So how many moles of oxygen will you require? Yeah, it will be 3 times 2, 6, and then here plus 4, 10. So you're going to require 5 moles of oxygen here, and that is how you balance that equation. Next question is, calculate the standard heat of combustion of propane. How do you get this one? So we'll check what is the enthalpy of combustion of carbon, or what we call graphite. 1 mole is minus 393 kilojoules per mole. Enthalpy of combustion of hydrogen we have seen is minus 286 kilojoules per mole. But the enthalpy of formation of propane is minus 104 kilojoule per mole. Now what do? Yeah, you just put that formula down. The formula is simple. That enthalpy of formation is gotten by the enthalpy of combustion of the reactants, carbon and hydrogen, minus the enthalpy of combustion of the product. The product formed is propane. So the enthalpy of formation of propane, we've seen it is minus 104 kilojoules per mole. Here we can see that what is the enthalpy of combustion of 1 carbon? We saw it is negative 393, but there are 3 of them here. The enthalpy of combustion of 1 hydrogen, 1 mole, is minus 286, but there are 4 moles here. So we're going to calculate the enthalpy of combustion of the reactants, and then minus the enthalpy of combustion of the product propane, which we are calculating, which we don't know whose value you're looking. That is what you're going to be, or that is what is going to guide us to get what we are looking for right now. Yeah, we're looking for the enthalpy of combustion of the product, which is propane, or what we call the standard heat of combustion of propane. Now, when we have calculated the sum, or when we have gotten the sum of the enthalpy of combustion of the reactants for 3 carbons, or 3 moles of carbon and 4 moles of hydrogen, we found that the enthalpy of combustion of the reactants is minus 23 kilojoules. So minus the enthalpy of combustion of this propane is what is going to give us negative 104, which is the enthalpy of formation of propane. So when this minus 23 goes to the other side, it will be positive 23. But on this side, mathematically, the minus sign remains on the x. So when you add, it will be 2219, positive 2219 is equals to negative the enthalpy of combustion of propane. For us to remain with the x, we divide by negative 1, then we will find that the enthalpy of combustion of propane is negative 2219 kilojoule per mole, and that is how you calculate the enthalpy of combustion of the product formed.